Welcome to Section 4 of Reproductive Embryology. In this section, we'll be discussing errors of morphogenesis. Let's get started. Let's start with the definition of morphogenesis. Morphogenesis is the biological process that causes an organism to develop its shape. When morphogenesis is disrupted, there are several types of abnormalities that may be seen, and we'll discuss each of them in detail throughout the lecture. Broadly speaking, you should recognize that there are two major types of errors: intrinsic errors and extrinsic errors. Intrinsic errors of morphogenesis can be defined by the failure of the embryo to develop due to abnormal genes or other internal processes. Examples of intrinsic errors include agenesis, aplasia, hypoplasia, and malformation, which we'll discuss in a moment. Extrinsic errors are external factors within the womb that disrupt normal development. In other words, it's not the developing embryo that's causing the error, it's something external to the embryo. Examples of extrinsic errors include deformation and disruption. All right, with this background, let's discuss intrinsic errors first, and then we'll move on to discuss extrinsic errors. The first intrinsic error we'll discuss is agenesis. Agenesis is defined as an absent organ due to absent primordial tissue. A great example of this is renal agenesis. This is a defect in the fetus which results in absent kidney development. Because the kidneys are essential for amniotic fluid production, less amniotic fluid is produced, which is also called oligohydramnios. The fetus is compressed due to less surrounding fluid, which creates a sequence of complications known as Potter sequence. Some of the findings include pulmonary hypoplasia, flat facies, club feet, and wrinkly skin. We discuss this in much more detail in renal embryology. Next is aplasia. Aplasia is an absent organ despite the presence of primordial tissue. This is different from agenesis because there is no primordial tissue present in agenesis, whereas in aplasia there is. An example of aplasia is DeGeorge syndrome, which is aplasia of the thymus. This is due to failure of the third and fourth pharyngeal pouches to develop, and it results in thymic, parathyroid, and cardiac defects. It also results in abnormal facies, which is pictured here on the right. Next is hypoplasia. Hypoplasia is underdevelopment or incomplete development of an organ or tissue. Our example of hypoplasia is Klinefelter syndrome, which is characterized by an extra X chromosome in males, resulting in 46XXY. This results in testicular hypoplasia, or small testes. Reduced size or incomplete development of the testes results in low testosterone, which gives the affected patient a more feminine appearance, including an increased amount of breast tissue and less body hair. The last intrinsic error of morphogenesis, which we'll discuss, is malformation. A malformation is an intrinsic disruption that occurs when a structure is not formed, partially formed, or abnormally formed during embryonic development. This occurs during weeks 3 to 8. Holoprosencephaly is an example of this. We discussed this disease in depth in our neuroembryology video, but briefly, this is a defect of forebrain development that results in midline defects and CNS deformities. It presents on a spectrum of severity, with the most severe form resulting in cyclopia, pictured here off to the right. Notice that in this disease, the patient has a single eye in the midline region right here. Okay, now that we've finished talking about intrinsic errors, let's move on to extrinsic errors. The first error is deformation. Deformation is defined as an abnormality of the position of body parts due to extrinsic intrauterine mechanical forces. Unlike malformation, which occurs during the embryonic period, deformation occurs after the embryonic period. An example of this is when a mother has a septate or bicornuate uterus, and this can result in compression of the fetus and a flattened skull. Last but not least, we have disruption. Disruption is defined as secondary breakdown of a previously normal tissue or structure. It can result from a vascular or mechanical process that leads to tissue compromise. A classic example of this is amniotic band sequence, or ABS. This is a rare condition that occurs when strands of amniotic sac get entangled among the fetus's digits, causing them to lose circulation via formation of constrictive rings, which then results in the development of limb defects. Off to the right, we can see an example of this right here. Notice that the fingers are much smaller than normal. All right, now that we've covered the type of errors, let's review with a practice question. A 3-day-old boy is brought to the clinic by his mother due to difficulty feeding. She is worried that he is starving, and nothing she does helps him feed better. On physical examination, the newborn is well appearing, but is found to have a cleft palate. What type of error of morphogenesis best describes this patient's presentation? A, agenesis, B, aplasia, C, hypoplasia, D, malformation, or E, deformation? Okay, hopefully from the question set, you notice that this is pretty straightforward. In what type of malformation do we categorize a cleft palate? A cleft palate occurs when a structure is partially or abnormally formed and is a midline defect. This falls into the category of malformation. So D is the correct answer. Agenesis and aplasia are incorrect because there is no organ missing. Hypoplasia is incorrect because, again, all organs appear to have developed normally, and there is no mention of underdevelopment, but rather abnormal development. In other words, I like to think of hypoplasia as not growing enough, whereas malformation means it grew, but in an altered way. So again, C is incorrect. Finally, deformation is incorrect because deformations are due to extrinsic forces, while a cleft palate is an intrinsic force. So again, the correct answer is D, malformation. And with that, we've covered everything you need to know regarding errors of morphogenesis.